Southwest Mock 2026, Paper 1. This is question 27 under Engineering Science for intermediate level technical school students. Grammar school students offering physics at the ordinary level will also need this question. The question says the arrangement of elements in the periodic table is such that grouping is based on A. Mass number, B. Number of valence electrons, C. Color, D. States of matter. So this chemistry question is asking us what criteria is used to arrange elements into groups. Well, if you look at this periodic table, you will see that here I have simplified the periodic table for the ordinary level, and you're expected to know these first 20 elements. I've arranged the elements into groups. These are group 1 elements, group 2, group 3, group 4, group 5, group 6, group 7, and group 8 elements, or group 0 elements, also known as noble gases. And so the first thing is that these elements are assigned numbers from the first element being hydrogen, 1, 2, 3, 4, 5, 6, 7, right up to the last one being calcium. So we have had hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. These numbers are called atomic numbers. So the first answer option says the elements are arranged by mass number. This option cannot be correct because the elements on the periodic table are actually, as we have just seen, they are actually classified by not the mass numbers, but the atomic numbers. And these atomic numbers, or the number of protons, increases as you go across, but it doesn't determine the group in which the elements are placed. We don't place them in groups using this mass number. The second option that was given in the answer options is the color. Does the color of an element determine which group or the group in which it is placed? No. It is true that metals are generally silver gray in color, but color is not a scientific basis for arranging elements into groups as we see here. What about states of matter? States of matter, as we know, are generally solids, liquids, and gases. So do we arrange these elements based on the states in which they occur in nature? No. The states in which elements occur are not the basis on which they are arranged into groups. And so here, the only criteria used to organize these elements into groups here is what we call the valency, or the number of valence electrons. So B is the correct option. What are valence electrons? This is the second question in this same paper on this topic. If I was to write down the electronic configuration of the first group 1 element being lithium, it has 3 protons. So lithium has 3 protons. That will be 3 electrons also for a neutral atom. So I will write the configuration as 2:1. The first shell takes 2, the second shell takes 1. Notice that the last electron in the outermost shell of lithium is 1. Lithium has a valency of 1, or 1 valence electron. If I was to write down the electronic configuration of the next group 1 element being sodium, sodium has 11 protons. That will be 11 electrons in a neutral atom. So we will write that as 2:2. The first shell can take 2 electrons only. The second shell can take 8 electrons only. That's 2:8. That will be 10 electrons. So we have one more to reach 11. So the last electron will be in the last shell, or the third shell. We'll call that the valence electron. Again, sodium has a valency of 1, or 1 electron in its outermost shell. That's the next group 1 element, just like lithium. What about potassium? Potassium has 19 protons. That will be 19 electrons in the neutral atom. So if we were to write the electronic configuration of potassium, we also have 2:8:8. This is 16 plus 2, that's 18 electrons. One more electron to make up the 19. And if we put the 1 electron here in the outermost shell, notice that potassium also has a valency of 1, or 1 electron in the outermost shell. It means all the group 1 elements have 1 electron in the outermost shell, or a valency of 1. It is on this basis that they are arranged into group 1, or placed in group 1. The same rule follows for group 2, group 3 elements, right up to group 8 elements.